In this lesson, we'll take a look at polynomials of degree 4. If p of x is equal to ax to the 4 plus bx cubed plus cx squared plus dx plus e, then by the fundamental theorem of algebra, we can write it as a times x minus r1, x minus r2, x minus r3, x minus r4, where r1, r2, r3, and r4 are complex numbers. And then, by Vieta's formulae, we have that the sum of all the roots is equal to negative b divided by a. And in our notation, we can write it like this, the sum of alpha. So the sum of all the roots is negative b divided by a. And then the sum of all pairs of different roots multiplied together is equal to positive c divided by a. And we write that as sum of alpha beta. And then negative d divided by a is the sum of any 3 out of the 4 roots added together. And in our notation, we can write it as sum of alpha, beta, gamma. And then lastly, all 4 of the roots multiplied together is positive e divided by a. And, well, if we're sticking with these Greek letters, we can write it as alpha, beta, gamma, delta. Alright, so pretty easy to remember, I think. Sum of alpha beta, sum of alpha beta gamma, sum of alpha beta gamma delta. B, C, D, E. Negative, positive, negative, positive. So it's a fairly easy pattern to remember. Exercise 1.9. The roots of the quadratic equation, quartic equation, quartic means to the power of 4. Quarter, 1/4. So quart means 4. Anyway, the quartic equation, z to the power of 4 plus 2z cubed minus z squared plus 3z plus 2 equals 0, are alpha, beta, gamma, and delta. By making use of a suitable substitution, find the equation with roots to alpha minus 3, to beta minus 3, to gamma minus 3, to delta minus 3. So our invertible function f is f of z equals 2 times z minus 3, and we know that p of f inverse of z is equal to 0 for all of these things, and then f inverse of z is clearly going to be z plus 3 divided by 2, and then by function composition we just go ahead and put that into our polynomial, z plus 3 divided by 2 to the power of 4 plus 2 times z plus 3 divided by 2 cubed minus z plus 3 divided by 2 squared plus 3 times 2 plus 3, wait, not 2 plus 3, z plus 3 divided by 2, and then I ran out of space, plus 2 equals 0. Okay, so that's our quartic equation, and I'm going to spend the rest of this video calculating it out. Maybe you would want to stick around if you want to get ideas on laying out the working in a way that makes it less likely to make a mistake. But if you're generally pretty good with this thing, then yeah, it's up to you. Okay, so first thing I will do is make it 1 over 2 to the power of 4, so 1 over 16 times z plus 3 to the power of 4, plus, and then we got 2 over 2 cubed, so that would be 1 over 4 times z plus 3 cubed, and then minus 1 over 4 z plus 3 squared, and then just plus 3 over 2 times z plus 3, and then plus 2 equals 0, and then from there times everything by 16 to get rid of the fraction. So z plus 3 to the power of 4 plus 4 times z plus 3 cubed minus 4 times z plus 3 squared, and then plus 3 times 8, so 24 times z plus 3, and then 2 times 16, so plus 32 equals 0. Alright, and then from here use binomial theorem to expand everything. So z to the power of 4 plus 4 times 3 times z cubed, so 12z cubed. And then 4 choose 2 is 6 times 3 squared, so 6 times 9 will be 54, and then z squared, and then it's going to be 4 choose 3, so 4 times 3 cubed, and 3 cubed is 27, times 4 is 108, so plus 108 times z, and then lastly just plus 3 to the power of 4, which is 81. Alright, so that's the first expansion done. And then for the next part, we still expand it out, but you should line up the z cubes, z squareds, and z and constant terms. And if you're still worried you're going to make a mistake, which I personally am for myself, you can even just do it in steps somewhere else. So 4 times z cubed plus, and then it will be 3 times z squared, so 9z squared, plus 3 times 3 squared times z, so that will be 27z, and then times, plus 3 cubed, so 27, and then all of them get multiplied by 4, so that will be 4z cubed plus 36z squared, and then 4 times 27 is 108, so plus 108z, and then 4 times 7 is 108, so plus 108. Alright, so putting that back into our working, so we got 4z cubed, so still being added, plus 36z squared, plus 108z, and then plus 108. And then next up we can deal with 4 times z plus 3 squared, which is a bit easier. So 4 times z squared plus 6z plus 9, and that's equal to 4z squared plus 24z plus 36, and that's all being subtracted this time. So minus 4z squared minus 24z, and then minus 36, and then we have plus 24z, and then plus 3 times 24, gosh, what's that, 72, and then lastly just plus 32. And then we got to add all that up. Oh, by the way, the whole thing should equal 0. Okay, so doing our addition, we get z to the power of 4 plus 16z cubed plus 86z squared, and then those ones disappear, so it's 216z, and then just simplifying a few of these easy ones, 108 and 72 makes 180, and minus 36 and plus 32, so minus 4, so plus 81, wait, what am I doing? Plus 81 plus 180 minus 4, so that would be 77 plus 180, so that would be 257. Right, so that should equal 0. And so that is our quartic equation with the roots that we needed it to have. Okay, so in further maths, you're going to have to do a lot of questions that do require a bit of long working, like this. In practicality, you would just do these calculations on the computer if you were using it for something. But in your exam, you're going to be doing it by hand. And, well, mostly by hand. I mean, at this point, you can type the numbers into the calculator if you prefer. But you still need a good way to lay things out so that you don't make mistakes. Because if you're looking to get A star, you can't make many mistakes.